In this video, we are going to introduce a couple new formulas for finding the area of a triangle. Now, when it comes to a triangle, there is an area formula that I imagine a lot of us probably already know, which involves knowing the height of a triangle and the base of a triangle. Now, in this regard, the area of a triangle would be equal to 1/2 times the length of the base times whatever the height happens to be. Now, while this is nice to know, it would be nicer if we had perhaps a shortcut or two associated with doing this. So what I'm going to do is label a triangle like we've been doing, and then talk about how we can use this area formula to derive one that will go a little bit quicker. So what I'm going to do is sketch in our three angles. We'll call them alpha, beta, gamma. Across from alpha we put A, across from beta we put B, and across from gamma we put C. Now I'm going to draw in what would normally be considered the height. I'm going to point out that the height actually splits this triangle up into two right triangles, and therefore we could use a little bit of right triangle trigonometry to solve for what the height is equal to. Now with that in mind, I'm going to take a look at the right triangle that's formed on the left side of the triangle. From the perspective of the angle alpha, H would be the opposite side, and B would actually be the hypotenuse. So to relate the opposite and the hypotenuse, I'll point out that the sine of alpha is going to be equal to that height over B. Now solving this for the height would give us that H is equal to B times the sine of alpha. Now if I were to take that and plug that into this area formula, I would get the following. 1/2 the base. The base in this case would be the side that's perpendicular to the height, so that would be C. And then the height we just solved would be B times the sine of alpha. I'm going to reorder this in a slightly different fashion and actually order this as 1/2 times B times C times the sine of alpha. This is one of three different area formulas that are referred to as the, oh boy, okay, no red pen. This would be considered the side angle side formula. The side angle side formula is so named because the three things that create this area formula would all be aspects of a side angle side triangle, put in that order. Now the side angle side formula actually works if you use any of the three angles. For example, if we had used the angle beta, beta would be the angle for the A, beta, C side angle side triangle. So in that regard, this would also work as an area formula. 1/2 times A times C times the sine of beta. Additionally, if we were to do this with the angle gamma, then A times B times the sine of gamma. So all three of these formulas are referred to as the side angle side formulas. We'll demonstrate how to use that in an upcoming video. There is one additional area formula for a triangle. That is the side-side-side formula. If you know the three sides of a right triangle, or excuse me, of any triangle, you can come up with the area of it. The side-side-side formula is also known as Heron's formula for the mathematician that generated it. So first thing we're going to do is define a variable. That variable is going to be referred to as S. S stands for the semiperimeter of a triangle. Now with that in mind, semiperimeter is so named because semi refers to half of something, and perimeter refers to the sum of the three sides of a triangle. So semiperimeter of a triangle would be A plus B plus C all over 2. Heron's formula states that if you know the semiperimeter, then the following calculation will give you the area of that triangle. Take the semiperimeter times the semiperimeter minus each of the three sides, all multiplied together. Now, to give a quick demonstration that this formula is in fact accurate, I would like you to consider what is probably my favorite triangle of all time, the 3, 4, 5 right triangle. Now, if we were to use the first formula that we had for the area, I would point out that 3 would be a good base, and that 4 would be a good height of this triangle. So if we go 1/2 times the base times the height, and simplify as much as possible, that would simply be 6. According to Heron's formula, though, the semi-perimeter of the triangle would be 3 plus 4 plus 5 all over 2. The perimeter would be 12, so the semi-perimeter is going to be equal to 6. And according to Heron's formula, the area of this triangle, not the semi-perimeter, is going to be equal to the square root of the semi-perimeter, 6, times the semi-perimeter minus each of the 3 sides. So 6 minus 3, 6 minus 4, and 6 minus 5. Simplifying this according to the order of operations, we take care of what's inside the parentheses first. That'll be 6 times 3 times 2 times 1. Multiplying those quantities together, 6 times 3 times 2 is 36, and then of course times 1 would still be 36. What we get for the area by using Heron's formula is 6. No, wait, not that. Okay, alright, there we go. That's the area I wanted. Comparing the two areas, we do get the same result. Granted, this is probably going to be the better way to go. I just want you to know that there are multiple ways that you can approach one single problem.